Hacking is an understanding of the security and especially how to work around that security. To understand what I mean, imagine you're in jail, okay? It's not only for computing, it's for the real world too. You're in jail and you want to escape from that jail. So there is security around you. There is camera, there is agent walking. So you look at where are the camera, where are the agent, what time they pass through. This is all the information, and then you may you may see a failure in that security. Maybe an agent is not looking enough. Maybe at a certain period of time there is nobody. So when you found uh, a vulnerability like this is where you prepare your plan to escape. In computing, it's something, it's like that. Security exists, you have to understand that security. We will see security on Linux today, and we will see also some breach because we will be better to understand the security. We will be able to identify breaches, and then we're gonna work with that breaches to hack a Linux server. For sure, the purposes of this training is for you to be a cybersecurity, to find a cybersecurity job and do ethical hacking for your company, not not to do bad things with it. So let's start with permission. You can see on my Windows, today I have 3 windows open. I prepared 3 user. Eric is one user, and Eric is part of group sysadmin and shipping group. So this is my primary group, and this is all my secondary group. I can have many groups. Add user is the command to add a user, and you also have add group if you want to add new group on your server. I also have Inaya, sorry. Inaya, she is another user and she's part of sales department for that exercises. I also have Mohammed. Mohammed is part of the shipping department. So I have many users: Mohammed shipping, Inaya sales, and myself sysadmin and shipping. Because sometimes I can do some shipping. So this is a real life example. In a company, you have group like that, and people have permissions together. Let's start by creating a folder where we will play with these permissions. First, let's go to /folder and see how permissions are set about the root directory. Slash is the root folder. You can see here the first letter D. The first letter is the file type. In here, it's a D means this is a directory. When there is a dash, it's a normal file. When there is an L, it's a symbolic link. The first character identifies the kind of file, a normal file, a symbolic link, a directory, things like that. If we get back here, the 3 other character means read, write, execute for the owner of that file. So the user root have read, write, and execute on that /folder. And then you have the group. The 3 other letter read dash means There is no write permission and execute. There is only read and execute for every member of root group. And then you have other. Every other person on that computer, there's not root or not part of the root group. They have read access and execute access. But be careful, when it's a directory, execute access means you can go in that directory. Because it's a directory, it's not an executable. So the executable here for a directory means that you have access to it. You can see into it. Permissions. I'm gonna tell you a little bit more about binary and octal number. You know, in binary, the number 1 is written like that. Number 2 is written like that. I use 3-bit in my example because an octal number use 3-bit. And then 4 is written like that. So I don't know if you remember your binary, but 1, 2, and 3. This is 1, 2, and 4. This is what I wrote on my screen. The read here, it's the bit like that. If I want read only, I should set the first bit on these three letters. If I want read write, this is the bit I have to set, read and write, no execution. If I want read write execute, I can set the bit number 1, the bit number 2, and the bit number 3. This is the way it works. Let's start by creating a permission directory. For sure, Eric do not have permission to do that because Eric is not root, is not part of group team, and any other don't have access to write in that directory. So I'll be root for this just to create that permission because we're gonna play in that permission folder to avoid making mistake in other directory of the operating system. As you can see, the folder has been created, is owned by root, and Eric or Inaya or Mohammed still doesn't have access to it. I'm gonna change mode. This is to change the permission of a file. So you remember I told you about the bit. I'm gonna put 000 to /permission just to show you. Now there is no permission at all to anybody. If I want to give root some privilege, so you remember the bit 1, 1, or 1. This is binary information, but you're gonna put an octal number here. If you want to put read-only permission, you should do that in octal. This read 4. If I put 400 on /permissions, I have read only for root. If I put 444, I have read for root, read for any member of the group root, and read for everybody else. If I prefer to set the second bit, like this, as in binary, I should put like that. That will be my write permission. In binary, this read 2. This is the number 2. I can put 2 to, let's say 4, 2, and 0. So read only for root, write only for the member of the group root, and no permission at all for anybody else. I have read, write, and nothing for the rest. So this is how it works. So let's start with that permission things. I'm going to put it 777. So 777 mean the read is activated, write, and execute. All bits are set in my octal number. It's 777, and then I have my folder and the permissions are there. So now Inaya is able to go to that permission folder and Mohammed too. Now I'm gonna teach you in that folder making some permission things. Don't forget the purpose of this is to understand very well the permission, so you will be more able to find breaches in the permissions and fix the computer to improve the security in your company. I'm gonna leave root now. I'm a normal user. I go into this folder. So let's imagine now that I'm gonna create a file. Let's say touch EEE like this. You can see now the file is owned by myself. It's no longer root. Root is no longer involved in this. It's Eric create the file. The owner of that file is Eric. Eric is a sysadmin group. The permissions are read write for Eric. Read for any member of sysadmin. Any other sysadmin can read the file, but they won't be able to write in that file. And if you are not Eric or not part of sysadmin, you are not allowed to read, write, or execute that file. This is a good example with that person. That person is not Eric. It's not a sysadmin. So if I try to read this file, you have a permission denied. I can't read that file. So this is how it works. Remember now, every time you create a file in Linux, as you can see here, the file permission has been set to read write, read, and nothing. This means 640. You remember that. You remember 6 because you have the bit number 4 and 2, but not the 1, so it's 6. 4 here because you have 4, but you don't have 2 and 1, and 0. But every time you create a file in Linux, the default permission are 666. And when you create a folder, the default permission is 777. But why is it 666, the default, and I don't have 666? Because there is a umask involved in it. The umask actually is 27. So that means when I put 666, okay, forget about the first number at this moment, please. We're going to see only the 3 last numbers. When I create a file, the file, as you remember, it's 666, but a umask is applied to it before. The first bit, no bit is going to be turned off by default. So 6 remains 6. Here, the bit number 2 will be disabled. So 6 will be 4. And here, all the bit number 4, the bit number 2, and the bit number 1 will be disabled. So 6 may remain to 0. This is why we have 640. In fact, it's 666, and the umask is applied. Let me change the umask to show you something. I'm going to put the umask 000. Now, if I touch a file called R like this, you can see my file is 666. It has been created 666. So now it makes sense what I'm saying. If I prefer to use a umask of 022, same thing. I touch a new file, y, and now my file is read write and read read. But a good umask that I suggest you is 027. 0 because the owner of the file is allowed to do anything with his file. Member of his group are not allowed to write into that file, and any other don't have anything to do in that file. As an example, if I work in a company and I write a document, I create a documentation, I'm responsible of that documentation. So the member in my team are allowed to read it, but I don't want them to write in that file, to modify my documentation. If they have an ID, I made a mistake in my documentation, I prefer my coworker to tell me that, and then I'm gonna fix my documentation because it's my documentation, I'm responsible of it, but they can read it. But even if a UMask is like that, this is for the default creation, but there's nothing, you can change the permission. If you said, okay, on EEE, this specific documentation I did is for everyone. So I want to add read permission to other. So I can put other plus read permission to the he. Change mode, chmod. This is the right command. And then now you have EEE was no other have no access to it. Now other have read permission. So you see now how change mode work. Other for other you can add the read permission, you can add write, and you can add execute. If you want to do it for the owner of the file, the user, you can add the user execution on it, and now you have the user execution on it. And you can also have the group, and you can mix both of them. User, group, and other have read, write, and execute. So you put, it's the same thing as doing change mode 777 for this. It's the same thing. There is many ways of doing it. Sometimes we are familiar with the bit and the numbers. We prefer to use numbers like 77 or 640, things like that. And sometimes we prefer doing with letters like group plus RWX, so you can do it that way too. So this is the how it work for that kind of things. Now all files belong to Eric. Let's have some other people also have some file in it. So let's imagine Inaya touch a file like that, and Mohammed also is touching a file like that. Now there is many files. Some files owned by Eric, some files owned by Inaya, and some files owned by Mohammed. Mohammed can go in his file and add some content to it. He's adding content like that. This is his documentation. And now we can see there is 59 character in that file. And that file is readable for everyone. That means that Hanaya is able to cat that file and see the documentation in the file. Mohammed will remove access to Anaya because he changed his mind. Change mode. Other minus read write execute on this file. So I want to remove read write access to that file. I want that file accessible only by myself or member of my group read access, but other people, I don't want them to read it. Now, if Anaya is trying to read in that file, she's not able to do that. She have permission denied. So now we understand the security. Is there a way to work around that? Let's imagine I'm going to try to find something to work around that. We're going to find, let's say, Eric. Eric have read access to it. But if Eric want to add something into this file, Eric have a permission denied because Eric can only read the file. He cannot write into that file. He cannot do that. But the workaround of this to bypass that security, because I absolutely want to write something in it, because I have read access, I can copy this file in /tmp. I'm going to call it abcd. So I made a copy of that file. And now because I have full access to this directory, I have write access in that directory. That means I can create file and I can remove file. So I'm going to remove Mohammed file. The file is write protected. Are you sure you want to remove it? The file is write protected, but the directory, I'm allowed to add file and remove file. So I'm going to remove that file. The file no longer exists. Now I can go in my ABCD file. I can add something. And then I can put back ABCD file here and name it like that. And now if I cat this file, it's the Mohammed file plus what Eric had in that file. So I work around that security. That security was not really hard. But the file now is owned by Eric. So Mohammed may understand that something happened. But this is a way of doing it. Now let's see a special permission. How to fix that. I'm gonna get back to be root. Okay. I'll get back to root because I need root to do that. Permission. And then I'm gonna change mode plus T. There is a special permission T on that /permission folder. So now you can see there is a T here. A T, it's a sticky bit. And just to give you more about it, you remember the umask? I told you to forget about the first number because it's for special permission. Here it is. Here we are. I put change mode T, but I can also put change mode 1777. So you remember 777, it's to allow read, write, execute, read, write, execute, and read, write, execute on that folder. And 1 is to also activate the sticky bit on it. So this is the same thing, the same result. You can do both, 1777 or plus T. I'm gonna leave root now. I'll be back to my Eric normal user. So as you can see here, Eric removed the Mohammed file and Eric has been able to modify the documentation. Now if I'm going back to Mohammed now see the file and Mohammed want to do the same thing. He want to do the same thing as Eric did before. So he copied the file in /temp. We call it mo.txt. Okay, I can do that. Why? It's because the file is owned by sysadmin, and Mohammed is not part of sysadmin. I'm gonna change group shipping. Eric was able, because Eric is sysadmin and shipping, and when Mohammed created the file was Mohammed and shipping. Because Eric is sysadmin and shipping, Eric was able to do it. But when Eric created the file was sysadmin, and he's the only one in that group. I'm going to change the group just to see the difference. Now the file is owned by Eric, and there is permission for shipping now. So I changed sysadmin by shipping, by doing change group on that file. I changed the group of that file. So now the file is owned by Eric, and my group shipping instead of my group sysadmin. Now let's see, Mohammed is able to cat this file. Yes, now Mohammed is able to do it. So now Mohammed will be able to copy that file in /tmp/mo.txt. You remember Mohammed want to do the same thing. He wanted to remove this file. This is a regular file, are you sure? But now I have operation not permitted. I was not able. And why? This is why the sticky bit has been involved. The sticky bit, when you have, before talking about that T, let's talk about the read write execute in a folder. You remember I told you when you have read write execute, you can create document and you can also remove document. When you put the T, it means, okay, you have read write, you can create document and remove document. But if you want to remove document, you can only remove the one that you own, not other one. This is the difference. And it's a major difference, in fact, that improves the security for you. Now, Mohammed is not able to remove an Eric file. Only Eric can remove an Eric file in that folder. And for sure, root have every access. Every time I say something, let's imagine that root, it's an exception to it. But this is for normal user. So this is how it works. So now we see the way we use permissions, and we understand how it works. So we found a breach. We work around that breach by removing a file and doing things like that. And now, because we know better, we fix the breach by adding a T, and now we are more secure now. I'll show you a new letter now, a new permission different. It's the switch user. Switch user. Let's imagine the Anaya. She want to hack the system. She want to be root, and she think she found a breach about it. She want to create a file, a program. I'm gonna call it a shell script. My shell.sh bin bash just to count the number of process in memory owned by root. And then I'm going to show my ID because I want to see what's going on with that. So I have a shell script now, change mode 777, because now I don't bother with the permission. And I try to execute that script. That script work, and I'm Anaya, part of sales department. There is a special something in permission, D plus S. S stands for switch ID. If I'm switching ID on my shell, You can see here an S and S. It means switch user ID and switch group ID. The person who's gonna execute that will now be Inaya and sales. It doesn't matter who it is, but it won't work. But let's start to understand that first. I'm Eric, and when I execute the script, it not really switch me to Anaya. I'm still Eric in the script, and I'm still sysadmin in the script because it doesn't work with script. This is why. It only works with binary. And the way it works, when you use a script, a bash file, this is a comment. When it's started by a pound sign, it's a comment. But when it's a pound sign plus exclamation mark, it's a special directive to the operating system. In fact, when I execute this, the operating system only able to execute binary. So we look into that file and say, okay, I have a special directive here. It's not really a binary. I need to use bin bash to execute the rest of these files. So it's not really brought in memory and execute normally. In fact, it's the same thing as doing bash. Doing bash space my shell, and in fact it's bash running, and bash doesn't switch our user ID. So this is why it's only working with binary, and I need something to switch that user ID. So I'm gonna create a binary. I'm gonna call it hackit.c. I'm gonna include stdio.h. I'm gonna include stdlib. I'll also include uni std.h. I'm going to create my main function. And now I'm going to use a set group ID 0, set uid 0. So I'm setting my group ID to 0 and to be part of the root group, and my set my uid 0 to be root. I will printf I hack it. And then I'm call a system bin bash. Why I'm calling bash? Because the way it works, when I will execute that, I'm in a shell, and in that shell I'm a normal user. Could be Eric, could be Ayana, doesn't matter, Mohammed. When I'm gonna execute that script, I will be root. But at the end of the script, if I'm going, if there's that at the end of that binary, the binary will get out of memory. I'm going to be back to my bash. I'll still be Eric. So I'm root for a nanosecond, and then I'm back to Eric. So it won't do anything. So what I'm doing is I'm Eric. I'm going to execute it to set my root things, and then I bring another bash above of it. In that bash, I'll be root on this one, because if I leave the first one, I'm back to Eric, so it doesn't do anything. So this is how the way it works. Let's compile that. It's the same output file name, compilation terminated. Okay, let's see that. Now I have a binary. I will change mul plus s to switch user ID. And now I'm Anaya. Let's try to run that. I hack it. I'm still Anaya. because the switch UI user ID is bring me back here. And you remember, if I look into the process, I have a bash. I call hackit, and hackit give me another bash above it. I'm gonna exit. So I exit the bash, exit the hackit. Now if I'm doing PS, I'm in my normal bash. Let's try Eric to run it just to see if there is a difference. So I'm Eric. I have the switch user ID to be Inaya, and Inaya should bring me to root. I'm still Eric. The reason why is because only root can execute this instruction. This instruction are there, but they won't do anything because you are not root. You need to be root in execution at least, and the way to be root in execution, you have to change the owner of that file. You need to have that file to be root. And for sure, only root can do that. So you're not allowed to do it. So this is why the security of Linux is pretty good. But I told you about security. We know the security now, we know the permission, things like that. We have to find a breach just to put our root over there. And the breach, most of the time, operating system are good or secured and things like that. But it's the human behavior using that computer insert breaches. If I'm looking to, I know that sudo bring you roots at some time, and let's imagine that in a moment the shipping department asks to have a special script, and the uh, the sysadmin did that script. Everything was fine, really secured, everything worked fine, but over time that script is no longer used because the company restructured, and then because of their restructuration we don't no longer need that script and the folder does not exist, but they never clean up the sudo file. This is something happened in real life. So this is a breach over here. I have a breach. I can use that breach to be root. How? I'm going to show you. I can create dir22 folder because it does not exist, and into that dir22 I can create a file, a script called shipping.sh. That shipping.sh, what I want to do, I want to change owner root of my permission hackit binary, because I know when I will run shipping with sudo, I know that my execution will now be root. Now that script will be able to change the owner because I wasn't able to do it. But that script running with sudo is going to be elevate at root execution. Because that root execution, I'm going to be able to change the owner of my file. And I also need to change mode to add the S, because by doing the change owner, the S will be removed. So I need to put back the S later. Okay, I'm going to clear that up. You remember hackit is there, the owner is Anaya, and the S is there. But I need that to be root. I'm going to do sudo -l, sudo, and in sudo I need to run that script. Command not found. Okay. Did I wrote it properly? It's there. Oh yeah, it's not found because there is no execution on it. I need to add X. You remember I need execution permission. Now I have execution permission on my script. Let's try sudo to run that script. No such file or directory. Now we can see the message is different because I may have an error in my script. Oh yeah, I put user bash instead of bin bash. Let's try again. Oh, now it has been executed. Let's see the difference in my Hackett. You can see now Hackett is owned by root and they have an NS over here. So now it should be better. If I'm looking to my ID, I'm Inaya, part of the sale department. And if I run Hackett, and now I'm root. So I hacked the system. I'm able to be root without knowing the password on that machine. So now I'm able to go into /etc and see special file like shadow, and I have access to the root password encryption, or not only root but many other user, they have password. So now I can use that hash code or password encrypted and try to run a brute force attack on it. So this is the way it works with permissions. I hope you enjoy. I hope you're gonna do good things with this teaching, with what I teach you. Don't forget, the reason of that teaching is for you to be a better cyber agent or cyber security agent. I want you to understand very well the way permissions work, for you to find breaches and then report that to your company to help them to improve their security. Because you found breaches, you make recommendation, and then the company will secure their computer because of you. Thank you very much. Hope you enjoy, and see you soon for another good video.